24 months. That's the strategic window before path dependency and the physical layer of AI locks in the next decade. Before the hyperscale data centers being poured, right now become the permanent geography of AI power. Before chip allocations, grid connections, and sovereignty frameworks harden into facts that are expensive to reverse. This isn't about dramatic collapse. It's about calcification. Once the concrete is poured, you don't get to reconsider the siting. So the question for this final episode is specific. Where does the leverage actually sit? Who can pull it? And is 24 months enough time for any of it to matter? Different layers of the AI stack respond to different interventions, at different costs, on different timelines. This is the part most policy discussions get wrong. They treat AI as one problem with one solution. It's 5 problems, each requiring its own intervention and its own budget. Energy and grid. The most expensive. Over $100 billion. Timeline of 10 to 20 years. Only national governments, utilities, and multilateral development banks can act at this scale. You don't solve the grid layer with philanthropy. Compute hardware and chips. $10 to $50 billion. 5 to 15 years. National governments and strategic alliances. Export controls sit here. So do strategic semiconductor investments and HPC co-financing. Inference-as-utility. $1 to $10 billion, 2 to 7 years. Governments, development banks, philanthropy, open source foundations. This is the layer where medium-cost investment could produce disproportionate impact. It sits between the prohibitively expensive grid and chip layers and the already saturated literacy layer. And it is the most neglected layer in current financing. Data and provenance. Low to medium cost. 2 to 5 years. Standards bodies, regulators, civil society. Licensing frameworks, provenance standards, data cooperatives. Cognitive layer, the cheapest. $10 million to $1 billion. 6 months to 3 years. Educators, employers, regulators. Curricula, verification tooling, certification programs. The pattern is clear. The interventions that are cheapest and fastest are also the ones with the least structural impact. The ones with the most structural impact take a decade and cost more than most countries can mobilize alone. The strategic question is whether anything in the middle, at the inference-as-utility layer, can be done fast enough and at sufficient scale to change the trajectory. Nobody is building public, safety-tuned, locally governed inference services at scale. That sentence is the single most important policy gap in this entire series. The World Bank's 2026 Development Report identifies AI infrastructure as a development priority. The African Development Bank, the Asian Development Bank, the Inter-American Development Bank collectively mobilize roughly $75 billion a year. The EU's Global Gateway program has a €300 billion mobilization target through 2027. The India AI Impact Summit in 2026 is an agenda-setting window for exactly this kind of investment. The money exists. The policy windows exist. What doesn't exist is the bridge between the evidence that says this matters and the financing decisions that would actually fund it. That bridge has 4 stages. First, pilots produce outcome data. Small-scale public inference services in 3 to 5 partner countries run on open-weight models with safety tuning, measuring reliability, cost, and governance outcomes. Second, evidence feeds advocacy at specific instruments, not generic reports. Targeted policy briefs designed for decision-makers inside the World Bank, the AfDB, the AdB, the EU, who control the relevant capital flows. Third, advocacy targets specific policy windows, the India Summit, the G20 Digital Track, AfDB and AdB annual meetings. Each has specific timing and requires specific framing. Fourth, capital gets redirected, not new money. Existing multilateral development flows, reallocated to include AI physical layer infrastructure as eligible investment, the way roads and power grids already are. If you had $10 to $15 million over 18 months, which is realistic for a well-funded research and advocacy coalition, how would you spend it to maximize the chance of triggering that Tier B redirection? 35% on Inference-as-utility pilots. Fund 3 to 5 small public inference services. Partner with open-weight foundations. Collect the operational data that development banks need before they'll commit capital. A modest data center being 5% on evidence and advocacy, timed to specific windows, not white papers for general audiences. Policy 5 shocks that could change the math. A hyperscaler capex contraction of 40% or more. This actually improves the economics of public inference pilots, because alternative capacity becomes scarcer and more valuable. The smart move in that scenario is to accelerate pilot rollout while hyperscaler attention is elsewhere. An empty construction site, political window for grid siting reform and distributed infrastructure. The risk is overcorrection into protectionism that also harms distributed access. A major AI safety or alignment incident. Regulatory response dominates everything. Human-in-the-loop mandates become likely. The cognitive layer investments in verification and supervision literacy become immediately, concretely valuable. The speed of regulatory response to crisis. Model collapse from synthetic data saturation. Open-weight parity stalls. Proprietary data moats become decisive. Clean training corpus initiatives and data provenance standards become urgent. Binding chip export escalation. Fragmentation probability spikes. Regional sovereign AI initiatives accelerate. The response is to build inference-as-utility capacity that is as block agnostic as legally possible. 5 physical layers. 4 scenarios. 1 strategic window. The base case, at 40%, is that the physical concentration holds and deepens regardless of what happens at the model layer. Open weights get better. Benchmarks converge further. And the deployment gap, the inference-as-utility gap, stays exactly where it is. The optimistic scenario, distributed rebuild, sits at 15%. And it stays at 15% unless somebody builds the bridge between the evidence that this matters and the financing decisions that would actually change the infrastructure. That bridge is the whole ballgame, not more research, not more pilots. The mechanism that converts pilot data into Tier B capital flows at the specific institutions, through the specific windows, on the specific timelines where the decisions actually get made. 24 months. That's before the current generation of hyperscale builds hardens into the permanent geography of AI power. Before grid interconnection queues close another year's worth of doors. Before the chip allocations for the next training cycle are already locked in. The window isn't dramatic. It doesn't slam shut on a single day. It narrows quietly, 1 contract at a time, 1 policy meeting at a time, 1 budget cycle at a time. Whether it narrows to nothing, or whether something gets through it, depends on choices being made right now. At institutions most people have never heard of. On timelines, most people aren't tracking. That's the story. Not which AI model you should use, not whether open source caught up, not how to write a better prompt. The story is who owns the physical infrastructure underneath all of that, and whether any of it can move before the concrete sets. The full report this series is based on, all the sources, the scenario framework, the policy windows and timelines, is linked in the description. If you work in development finance, in government procurement, in multilateral institutions, or if you just want to track the signposts as they develop, that's where to start.